Welcome back to Math with Miss Swartz. Today we're going to look at our first property of exponent rule, product of powers. And we've already looked at and kind of done an intro before you started the video here. We probably formulated, based on our chart, an idea of what the product of powers property is going to look like. So I'm going to throw up the description here. It says, let A be a real number and M and N be integers. And that's referring to down here what it's talking about. So what it's telling us here, a to the m power times a to the n power would equal a to the n plus n power. So it says to multiply powers with the same base, okay, it has to have the same base, and we talked about what bases are and those types of things in your notes. We're going to add their exponents. So we broke it down here. When we had this, we wrote 4 times 4 times 4 times 4 times 4 times 4, that's 4 to the 6th power. And then if we multiply that by 4 times 4 times 4, how many total 4s do we have? Well, if we add those together, we have 9 total 4s. That's why it's 4 to the 9th. So this is going to make our life a little bit easier than writing that all out. If we know the rule, we can just answer it as 4 to the 9th. So the rest of these slides are all examples today. So we're going to go through quite a few examples actually, because I want you to see as many examples as possible as you're working through this. A lot of these properties are really easy alone, but then we start adding in multiple properties at a time, and that's where things get complicated. So you got to make sure you have a good understanding of each property on its own. So here's our first example. We have 2 to the 4th times 2 to the 5th. Okay, so our base is the same. We're good to go there. We just need to add our exponents. We could write it all out, but there's no need. Our rule tells us if we have the same base, we add our exponents. So 2 to the 9th is our answer. Okay, for B, we have -5 times -5 to the 6th. Now, you may think, I don't have an exponent here. How am I supposed to do this, Miss Swartz? But remember, above any number, there is an exponent, okay? So if I just list out 1 or even 2, there's an exponent, because this would be 1 to the 1st power. 1, and then it's to the 1st power is just 1. 2 to the 1st power is just 2. So -5 to the 1st power, okay, if we add that little 1 up there, now we can follow our rule. We're going to add our exponents. So we're going to have -5 to the 7th power. Alright, so like I said, quite a few examples here. Let's start up top, pretty easy. 2 to the 4th times 2 to the 3rd. That's going to give us 2 to the 7th as we add our exponents. And we have 7 to the 5th times 7 to the 7th. Keep your base the same, add your exponents, and you can leave it in exponent form. Alright, we have 1/2 squared times 1/2 to the 5th. We have the same base, so we keep our base, add our exponents. And you just have to make sure you have the same base, really. -3/5 to the 3rd times -3/5 to the 3rd. It's going to be -3/5 to the 6th. Okay, 5, we have x to the 5th times x to the 11th. So we get x to the, add those together, 16th. Y to the 3rd times y. Okay, remember, if it's just y, we have that pretend 1 as our exponent, so this would be y to the 4th. Let's see if we can see this one down here. We got 4x to the 5th, y to the 3rd, times 3y x to the 2nd. Alright, for the first time, now we have multiple pieces going on. Okay, so this is number 7 that you can't see quite down here. So we have an x, we have y, we have x's and y's here, we have coefficients. Okay, so what we're going to do is we're going to multiply each piece individually. We're going to multiply our coefficients, because 4 times 3 is, in fact, 12, so we can do that. Then we're going to work with anything that has the same base. So 5x to the 5th and x to the 2nd have the same base, so I'm going to work with that. I'm going to add my exponents there. That's going to be x to the 7th. y to the third times y. Okay, remember we got that, pretend 1, so that would be y to the fourth. Here is our final answer. So as you can see, for the first 6, we really just had one variable or one base. We can have multiple bases and we can work with all of them within one problem. We're just multiplying each individual base that works together and adding those exponents. So we have a lot of examples of those coming up. Alright, so you can see here, we got quite a few problems here. So we have 11x to the third times 10x to the second. So we already kind of talked about, if you have coefficients, go ahead and multiply your coefficients. 11 times 10 is 110. Then x to the third times x to the second, well, those have the same base, so I can add my exponents, so that would be 5. Number 2 works the same way. 8 times 8 is 64. P to the 6 times P to the 6, well, we're going to keep our base. 6 times 6, or not 6 times 6, we're adding them. So this will be 12. Alright, so kind of a challenge. I want you to try 3 and 4. Okay, so with these, break them down. You multiply your coefficients, multiply any bases that are the same. Apologize. Multiply any bases that are the same, and add their exponents if you have those. If there's nothing there, like for example b to the fourth, you're probably not going to do much with that. So 4, even more challenging, has 3 different parts, but the same concept applies. Anytime you see a base that's the same, you're going to look to add your exponents. So try those 2. I'll be looking for 3 and 4. The last part on some of your homework is going to be working with some story problem type things. So it says the area of a rectangle is given by a equals length times width, right? Where L is length and W is the width. It says find the area of the rectangle given the values of L and W. So it gives you the values of L and W. So we're going to go area equals length times width, and then we're going to work with what they give us. So we want to find the area based on L equaling 10x, so I'm going to plug that in, times W equaling 2x. So you can see how this would work, because now we're multiplying powers. Product of powers, so 10 times 2 is 20. X to the first times x to the first is x to the second. So there's our answer. Same thing would work with number 2. Area equals length times width. If L is equal to x to the fifth and W is equal to 5x, we're going to have x to the fifth times 5x, so, well, 5 is not going to change. We're just going to add our exponents here, so we're going to have 5x to the sixth. So you'll have some problems like that. They may not use specifically the rectangular formula, and you may not see a ton of those problems depending on what you're doing. Alright, so that kind of concludes our examples. I would really like to see that you kind of know what you're doing on 3 and 4 here. But once that happens, we have a worksheet for you, and you can go ahead and get started on that. Have a wonderful day.